Take any object, for instance, this sheet of paper, and rip it in half. And then rip it in half again. And again. But how many times would you have to rip this piece of paper in half to reach the most basic unit of matter, an atom? The answer is about 85 times. The atom itself is composed of three pieces: the proton, the neutron, and the electron, all bond at the nucleus, and the varying amounts of protons, neutrons, and electrons that bond to the nucleus define which chemical element it is. Atoms are composed of electrons, protons, and neutrons within the nucleus, where most of the mass is contained. The electrons are negatively charged, the protons are positively charged, and the neutrons have no charge. The atomic number is the number of protons within the nucleus, while the atomic mass is the sum total of protons and neutrons within the nucleus. For instance, hydrogen with one proton in the nucleus has a number of 1. Helium, 2, lithium, 3, and uranium, quite a few. Iron itself requires several billion degrees centigrade to be formed in the belly of a star, but it is a dead end for atomic recombination, as it does not release energy when the nucleus forms. Heavier elements are formed when the gravity exerted on the star exceeds the energy it's dishing out, so to speak, and forms in a supernova. Most stars are giant balls of hydrogen and helium. The pressure exerted by gravity on these stars is so great that the core ignites, making it a giant flaming ball of hydrogen and helium. After a while, through nucleic recombination in the core, all the hydrogen and helium run out as it turns to metal, and when the star can't force enough energy out from the fuel, gravity becomes too great, the star collapses on itself, and the resulting crash is the supernova. Gravity itself is a curious force, once called a curvature of space. For instance, at zero gravity, you get some floating rhinos. They don't really know what they're doing, but they're having a good time and they're just floating around. At greater than 1 times our gravity, things start to squish, get flat, lay closer to the ground, and compress. A little greater, at 100 times, rocks fold over and collapse on themselves. Well, if you go all the way up to 1 billion times our gravity, light itself, a straight, perfect beam of light, will bend back on itself.
Down in Mississippi where the sun